No. Sorry, thank you. I'm like, that's a really easy question.
Yeah, I did.
It's either you did or you
I
didn't.
did
It's
do
crazy. Okay? And it didn't make sense.
It still didn't make sense.
So I need to know where we are with this. Okay.
I set it up.
So guys, real quick. Does everybody see what I'm saying? I don't know if you're at the point right now. You might have to look at it and think about it. If I gave you this problem on a test, on the next test, you would use law of cosines.
Yeah.
You just would. And you would hopefully would get there. And again, it's so dumb to memorize, oh, it's angle, sine, angle. No, that's bullshit. If you can make a complete ratio, what do I mean by that? If you have an angle and the corresponding side, that's a complete ratio in law of sines, that'll work. If you can't, use law of cosines. It's that simple. I don't have to memorize any angle, side, angle bullshit. Right? You guys are kind of with me. But this is in the law of sines section. I haven't even learned law of cosines yet, and that's why they do this extra thing. And of course it runs into, because it's a free book, that, draw a perpendicular from H to JK. So just drop that down. Doesn't that make two right triangles?
Yeah.
Yep.
So
Now, did you not understand how that helps, maybe?
I did that, and then I labeled that as like y, and then I tried to, because I was confused because it's sines, so I was using cosine, so I thought I was doing it wrong.
So let me say this.
Cosine 20 degrees, y over 7.
Wait, let me catch up. So if you drop this is right angles here. What angle would this be from?
Oh, I see now.
Now you made a right triangle. You don't know this length, do you?
Oh.
Right? You don't know that length because I don't know. I'm not cutting that in half. I don't know how much I'm cutting it in. So I know nothing about the bases of the two right triangles. So everybody with me? If you drop a perpendicular down, as if it were hot, and you would make two right triangles. I know nothing about either one of those bases. I don't, because I don't know how much I broke the 10 up into. I do know there's 7, and I do know there's 20. No question. So what could I get from that?
Well, since you dropped it down, one of the angles would now be 90.
Sure. So then you would know this angle, correct? So to solve the triangle, what am I missing to solve that? No. I mean, I need this side, correct? That's the only side I don't know. And then these two angles, correct?
Yep.
Okay. When you drop it down, you have two right triangles you can look at. Try to figure out how much you can get from them. Now, real quick. At this point, we also know inverse trig stuff. Let me see how much. All right, let me do a little more. Okay. I was trying to see how far I needed to go to leave it for you. Morning, guys. Hey. Oh shit. All right. Multimedia. Oh, I could do this. I've not done this. I'm gonna do this for these poor people over here. That did nothing. That did nothing. Oh. Oh, there it went. Okay, cool. Look at me go. All right, guys. So now you can see the triangle there. I'm going to try to copy it real quick using blood red pen. 10, 20 degrees, 7, J, H, K. Drop a perpendicular. Okay, right? Okay. Ooh, okay. This is 90. This is 90. If you wanted to, what's this? 70. I'm not saying we need it. That's not an angle I need, but if you wanted to put it there, sure. So what do I need? I need to know what this side is. We'll call it little j. How's that sound? Little j. I need to know angle. So I need to know little j. I need to know angle h. I need angle k. Is angle h 70? Shit, no. This is part of angle h, correct? Just keep track of what I need to know and what do I currently know. So how the hell is it going to help me figure out this? Well, this is a right triangle here, right? Isn't this a right triangle? Mm-hmm. If I could figure out two of its sides, couldn't I figure out the third side?
Yeah.
Can you figure out this side? Can you figure out how long this side is? Isn't that a right triangle?
Yeah.
Don't you know a lot of shit in that triangle?
Oh,
You can figure out how long this side is, right?
sides.
Huh?
Well, because we know the two sides.
No, you don't. No, you don't. 10 is this. How long is this? No freaking idea. How long is this? I know it's 10 minus x, right? I love you guys. But real quick, now watch. Don't I need to eventually figure out the length of this? So then I can start saying, man, I wish I knew this and this. If I only knew how long this side was and how long that side was, getting this is easy as shit because it's a right triangle I made, right? So then you can step back and focus. Okay, can I figure out how long this side is? Yes. How would you figure out how long this side is? Is it cosine?
It has to be sine.
Sine, 20 degrees, equals, we'll call this y, crazy enough. Sine 20 equals, sine 20 equals y over 7. Can you do something similar and figure out what this is? Could you figure out what this is? Could you figure out what this is?
Yeah.
Yeah,
We would
just
know
as
what-
easy, right? I love it. You guys are with me. Could you then figure out what this is? Would you then know what this and this are? Couldn't you figure out what that is then? I mean, do you start to see what I'm saying? You've got, I think sometimes students, you just want every problem to fall into a recipe and you don't accept that there's going to be multiple steps. You need to start expecting multiple steps. You need to start expecting it to not fall directly into a recipe. This one gave us a hint, thank God. Because if they didn't give us the hint, I would agree. This is like really crazy problem. Okay. Just to remind everybody, let me show you the problem again. If I gave you number 56 on a test, would I try to use law of sines? I could try, but I quickly see that won't work, which means what? Use law of cosines, right? But again, why don't we just use law of cosines? Because we haven't learned it yet in section 10.1. You cannot use something you learned in section 10.2 as you do section 10.1 homework. You can't. Yes?
But you can use section 1 homework when doing section 2. Like,
Oh shit, yeah, it builds. Yeah. In section 10.2, I'm almost certain there's going to be times where you have to use law of sines. Yeah.
so after we find the y, then you can.
If you find the y and you find this x, then you know what this is. Then you can figure out what this side is. And that's one of the things you got to figure out. And then how do you get the angles? Well, then you could use, then you got a right triangle, you use inverse trig. Because you know all the sides of that triangle, right? Okay. So it's a plan of attack. Keep track of what you know, keep track of what you want to know. And then go, and then very often, this is so oftenly true. Man, I wish I knew this. All right, can I get that? Man, if only they would have given me this. Okay, can I get that from what they did give me? Does that make sense? It's a very widely applicable approach. Man, I wish I knew this. All right, can you get that? I wish they would have told me this. All right, let me catch up with everybody. Who else came in? Oh, Maddie and John. So real quick reminder on how I graded these quizzes. It's out of 5. If you got a +0, that means absolutely nothing happens to you. If you got a +1, 2, 3, 4, 5, I'll divide that by 5 and add it directly to your quiz average. Right? You can make corrections. You can make corrections. I don't know how I'm going to grade them. I'll probably give a point back or something. Nobody got a 5. Somebody got a 4. There were a few 3s. I think the average was like a 1.6. Okay. Everybody paid attention to this up here? You see all these announcements? Is everybody bummed out about that, or?
No.
I don't really But, you know, it's funny I'm about to say this. I don't really like to move test dates, even though I've done it a few times. But a few people emailed me they had a rough Thanksgiving. I know that several of you guys are still kind of behind. I know that there are questions from the quiz, for example, that need time to understand and so forth. So I want to give one more day. What's going to happen is I'm going to do a few things today, and then we're going to go over 10.6 and 10.7. Those are not going to be on the test on Wednesday. And in fact, that homework, the homework for 10.6 and 7.7 won't be due until the day of the final. In fact, everything we do after the test is not due until the day of the final then, at that point, because that's the next test, right, after that. Everybody with me? After everything we've been through, I think you're going to enjoy, believe it or not, relatively enjoy 10.6, 10.7. Somehow it relates to Etch-a-Sketch. So we'll see how that goes. Yeah.
Okay.
We'll see. I'll show you.
For the practice test, is it still gonna be like on the test? So since we don't have 6 and 7 anymore?
No, that was not going to be on the test anyway.
Oh, it was?
Not well on the last homework. I said it would, but we didn't make it that far.
Oh.
So we only made it up to 10.3.
So
Everybody with me?
Practice test doesn't have anything on.
10.6 or 10.7? No.
Oh.
Yeah. Yes.
I have a question for the homework.
Did you have a question about this? Yeah. What's up?
Do you have the answer key for the practice
Yes,
test already?
I do.
Can we get that to you later or no?
No, I'm not. I'm going to hold them. I like them. No, I'm going to give them to you today. On 10. Okay. All right. One more question. 10. What one?
No, yeah, this one, yeah, just 27.
27. Okay.
Well, I just wanted to know if the equation I had to use was A equals 1/2 AC sine.
Yeah, I always forget that they do put that in here. That's a cool freaking formula. Oh, here it is. Do they actually show you why it's, yeah, they show you why it's true. I'm not going to kind of make you go through the derivation, but this is kind of nifty. This is the area formula for a, if you only know, let's see if they give us an example. What? That can't be an area problem. Okay, they don't do an example. I love it. That's awesome. They do sort of an example. So if you know A, B, and the angle between, let's see if they make that clear. So B, C, and the angle between. So if I know an angle and the two sides that make that angle, I can get the area of that triangle, which is different because what's the regular formula for the area of a triangle? 1/2 base times height. So if the base and the height are perpendicular to each other, that's a nice right triangle. That's easy as shit. If it's not a right triangle, the height is offset. So then you have to take a moment to figure, so what this really is, to be honest, how would I figure out that height? Well, I can make this little right triangle, I can figure out the height, correct? So they just sort of incorporate that work into the formula. So one step would be, what would the height here be? Let's see if you guys can get this. We know angle alpha, and we know the hypotenuse. What's the height? What trig function would I use? If I know the hypotenuse, and I know angle alpha, I want to know the height. What trig function is that? Sine. And I don't know, I really want you to be with me here. When I multiply a hypotenuse by sine of the angle, I get the part that's in the y direction. So all I have to do then is c times sine alpha. That's the y piece. And sure enough, look. And then I would multiply by the base. What's the base? B. So I do 1/2 c sine alpha base. Isn't that the stupid formula? Not stupid, I'm sorry. 1/2 c sine alpha base. So it's just two steps in one. Instead of taking a moment to figure out the height, you just throw the height work into the formula. Maybe.
Would that be a question on the test?
No.
Like for 27, you would do 1/2 times AC sine 35.
Yep. You gotta be certain So the real shortcut is, as long as the angle is neither one of these associated. You with me?
No.
If they told me A, B, and angle beta, I couldn't use that formula. I need a side, and the angle between.
Okay, yeah.
So these two sides have to be the other. See if I can. If I know angle B, I need A and C. If I know angle C, I need A and B. Otherwise, I don't have the sides that make the angle. I have the side over here, which does nothing for me in terms of the formula. That's the one thing you gotta be careful about. Since that's angle beta, and I know side A and side C, not side B, I'm good. I can do it. Okay. I'm not gonna make a big deal out of that. Apparently, because they didn't even talk about it. It's just a plug and chug thing now. Anything else from homework stuff?
Can you go over 65?
Oh, yeah.
Not 65. Yeah, just go over 65.
Yes, ma'am. Let's
Thanks.
see. It's all right. Do it now. You work for me. Oh boy, all these pilots. Pilots flying over a straight highway. He determines the angles of depression, 2 mileposts, blah, blah, blah. Does this sound familiar?
Yes.
Yes. Why? It was so gross before. Would you agree with me? And I get 110 there, and they get, oh, yeah, solve for a variable. I had to throw in the other thing. It looked disgusting. I had to put it in the calculator correctly. We're going to be able to do this problem using law of something. In this case, hopefully law of sines, which we didn't know before. It's going to make this problem a lot easier. One thing you could do for yourself, you can either draw the triangles up, so they're upside down, or you can translate the angles down here, right? So this one would be here, this one would be here. You with me? And then what do we know? They're 4.3, you know this side of this triangle. And you know 2 angles. I love it. So then you should be able to use law of sines. But if you draw it correctly, so this one you're not going to have to do it the way we used to. That's all I'm going to say for now. I want you guys to try to draw it. Now that we know more stuff, old problems should be a little easier. So I'll let you try. Now that you have an idea, you eventually want to get to a point where you can use law of sines. And it's really all about capturing those angles correctly. So let me be a little more direct. I got one triangle, right? I need to figure out what this angle is and what this angle is. And then I'll know what this angle is. In fact, we know what this angle is here, don't we? Does anyone know what this angle is right here? If that's 32 and that's 56, how much is this? If that's 32, that's 56, and that's 32, how much is that part? It's got to be 56 minus 32, 24. You guys see that? This one has got to be 24 because the whole thing's 56. Do you see that? Don't I then know the angle across from the side that we know? Isn't that a complete ratio with law of sines? Okay. Maybe. That's something that happens a lot, and I don't know how it comes off to you. As a student, it was neat to me to have a problem that was really gross. We learned something, and we go, oh, now it's better. But I can understand students getting angry. Why didn't you just tell me this before? Well, because we had to get there, damn it. All right. So let's do this. Let me see. I want to do a few things that I think have sort of fallen through the cracks a little bit. One thing I definitely want to do, because I got so stuck on making sure you guys got enough reinforcement of stuff like, if I ask you to solve this, you could do it, Jeff. There you go. How would you do it? What would you
Cosine of 1/2.
not cosine of 1/2, but cosine of what is 1/2? What angle does that relate to? Cosine of what angle is 1/2?
60.
Pi over 3. Good, you're both right. 60 degrees, pi over 3. You guys with me? So then and what quadrants are we in? First one definitely, because cosine's positive. What else?
Fourth one.
Fourth one, because that's also where cosine's positive. Kick ass. So what are my two base answers? Pi over 3. Yeah, 5 pi over 3. Kick ass. Chumbawamba. Oh man, I haven't had to write in a while, so you're going to have a lovely time. Sorry. Now, if I wanted all answers, what would I put on here? Because I can't capture that one on the way because these are not equally spaced, correct? Okay. So then this would be plus or minus 2 pi k, plus or minus 2 pi k. And then what's the actual final step? Divide by 2, because I want to know what x is. So some people on your homework, you're saying this, and then you're circling that or something. No. You're not done, right? Do you see what I'm saying? Also, how do I even say this? If I had cosine of pi over 3, what's that? Good. So what's cosine of pi over 3? I'm not asking you to translate the angle. I'm saying, what is cosine of pi over 3? So what if somebody wrote this? Does that make sense?
No.
Does cosine of pi over 3 equal cosine of 1/2? No. Right? So I'm still getting people that are having this linger. Okay. All right. So the last step here would be divide everything by 2. So you'll end up with pi over 6, blah, 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 blah. I don't care. All right. You guys with me? That's old shit. One thing I didn't do an example of because, just because. What if I had...
Do those twos cancel?
Which ones?
The
Here?
Yeah.
All the time.
Okay.
All day.
Okay.
Real quick, while I'm here, never would you do this. Does everybody agree with me? Doesn't make any sense. What? I was talking earlier, how would you solve square root of 2x equals 7? What would you do? Would you divide by 2? You would never divide by 2 because you can't break into a square root. You can't break into a cosine either. No. You guys with me? Okay. Hopefully you don't think I'm yelling at you. I'm just emphatic. Okay. Put in the emphasis. All right. So what about this problem? Cosine 2x equals 1/7. Now, real quick, if I said solve this, what's the answer? Come on. You could do it. Plus or minus 3, right? If I said solve this, do you just say I can't do it, or is there a solution? You can do it. What's this?
Just leave it square root.
Yeah, it'd be plus or minus square root of 7, right? Okay. So what's this? Can I do it the same way we did this first one? Get out of there. Get out of there. I could just look at it and tell. Right? Square root of 9, I can just look at it and tell it's 3 and then plus or minus. Square root of 7, I can't look at that and go, oh, I know this. So what do I have to actually do? Yes, take the inverse. So cosine inverse of, these kill each other. So now I know 2x equals inverse cosine of 1/7, correct? Now this gets a little silly. But I need you to understand something. How do I put this? Aren't there going to be, so one answer is going to be here, another answer is going to be in the fourth quadrant, the same way we had with this problem. So let me see if you guys can get this. This is this. You with me? Inverse cosine is a what? Inverse cosine is an angle. So this angle is this. Wouldn't cosine also be positive here? In the fourth quadrant? So what angle is this? It's a really easy answer. It's a really easy answer. Say again? No, hell no. It doesn't have to be the same angle just down there. So instead of going positive, can't you just go negative?
So would it be negative?
You could either do 2x equals negative cosine inverse, right? Or you could do Or you could do, does that make sense? How did you guys get 5 pi over 3? Didn't you kind of do without even realizing it, 6 pi over 3 minus pi over 3? Didn't you do 2 pi minus pi over 3? All right, so things get a little stickier when the question, the problem is a number I don't know which angle goes with it. 1/7, I don't know what the flip angle cosine makes 1/7, right? But I could do all the same stupid work. I just have to work with this weird ass, I don't know what the shit. You could plug that in the calculator, but it's always going to be an approximation, so why not just leave it like this? Does it make sense? And again, that is less important than this. But that doesn't mean this is not important. But this is more important. That's why I focused more on this. But in the homework, you will see problems like this, and that is tripping some people up. But it's the same shit. Right? If I said, give me an approximation to the square root of 16, you would say, square root of 16. 4, you're going to go, that I don't have to be approximate. If I said, give me an approximation to the square root of 15, you're going to flip and put that in your calculator, right? Okay. Oh, anybody need this from before? Yeah. Anybody need this real quick? Yeah? There you go. At least one person needs this. All right. Sorry. What's up?
If you push it down, like to the bottom.
Oh.
Okay. Where it says rectangular to polar, give me the inverse when you're using tan, like the tangent part.
Oh, here.
Yeah. What I have to use, like I would.
Yeah, let's do one. What are polar coordinates?
That's
R and theta.
R theta. Kick ass. These are what I call rectangular. What you will see in the book, I think sometimes they'll say Cartesian. I don't know if you remember that I told you the urban legend about Rene Descartes. Sick in bed, watching a fly walk on a ceiling, and he's trying to imagine this XY plane. So we call it the Cartesian coordinate system because some fever-dreamed mathematician back in the day, right? So that's what we base everything on. Sorry. So does somebody remember? So this is X and Y, correct?
Yeah.
All right. What's the most basic relationship between R, X, and Y? Because I got to figure out R and I got to figure out theta. So what's the relationship between R, X, and Y? Yeah, R squared equals X squared plus Y squared. So you just throw square root of 3 in, you throw 1 in, you take a square root. Okay, you guys with me? Right? So then R squared equals, square root of 3 squared is 3, 1 squared is 1. That's crazy, so then R is 2. Now how do you get the angle? No, look up here. Ooh. So what's tangent theta equal to? Y over X. It'll be 1 over square root of 3. That's an angle you should actually know, believe it or not, because that's rad 3 over 3. I don't know if you guys know that one. And again, the way I have this memorized, what's tangent of any pi over 4 or 45 degrees? It's going to be some kind of what? Tangent of 45 degrees. Tangent of pi over 4. 1, right? So every 45 degree angle, tangent is going to be 1 or negative 1. You guys all with me? If tangent's some kind of rad 3 or something, that's going to be 30 or 60. Tangent is biggest when sine is biggest. Why does that make sense? Because what's on top of tangent? Sine, which is basically, you guys with me? So tangent is biggest when sine is biggest because tangent's big when the top of its fraction's big. So when is sine, this one's small. This one's rad 3 over 3. Rad 3 would be the bigger option. This is smaller. When is sine smaller? Which angle is sine smaller at? Pi over 6 or pi over 3?
Oh, pi over 3.
6.
Pi over 6, yeah.
A 50-50 shot. So this is going to be pi over 6. Now, how do I know I'm right? What quadrant is that point in? Now, real quick, wouldn't this, gosh, it's just never enough time. Wouldn't this, that's in a totally different quadrant, correct? What quadrant's that point in? Third, right? But when I do this, wouldn't the negatives cancel? Wouldn't I still get pi over 6? Would that be correct? What quadrant was it supposed to be in? If it's this one? Third. So it would be a pi over 6 reference angle. It would be 7 pi over 6 to be in the third quadrant. You guys see what I'm saying? So when you're converting points, almost always when you're dealing with trig stuff, you think, what quadrant am I in? What quadrant am I in? That should be one of your first things you consider. What quadrant was this point in? 1. Okay, cool. That's going to be straightforward. Done. What quadrant is this point in? Why is it in the second? X is negative, Y is positive, second quadrant. So whatever answer I get, I better make sure it's in the frickin' second quadrant, right? You guys kind of follow? Okay. Otherwise, it is just plug and chug shit. It literally is just plug and chug, yes? You just have to know these. And if this is not clear, you have to memorize those. And you're like, dude, man, you only get so much of my memory, okay? You've already gone over. Oh, well, shove some more stuff in. I need those shoved in. Shove it in there. Okay. By the way, this is not new, right? That's not new. That's the definition of tangent, correct? That's not new. That's not new at all, right? And neither are these. These aren't new either. Do you kind of follow what I'm saying? So it's not like completely new stuff to memorize. It's just remembering how they're used in the situation. But there's stuff you already know. Okay, maybe. Look at this one real quick. What is r squared? So I'm trying to convert to rectangular. Trying to convert to xy. So I don't want any r theta. I want all x's and y's. Do you see anything that I can immediately put in place in terms of x and y? What's r squared? X squared plus y squared. So I can immediately replace that with that. Do you see anything here that's familiar? R sine theta is? Y. Done. I'm done. Anyone know what that's an equation of? Say again?
You just stopped there?
Totally. Anyone know what that's an equation of? What would it look like? A little tear. It's a circle. It's a circle who's got a different center. X squared plus y squared equals r squared is a circle, right? X squared plus y squared equals 1 is the unit circle. X squared plus y squared equals 5y has actually been shifted, well, in the y direction in this case. Chapter 12, we're going to talk about what's called, all right, it went out of my head. Elliptical, Jeff. Conic shit, right? We'll talk about where that came from as conic sections. There it is, Jeff. You did it. Anyway, we'll get there. And one, if I just chop a cone, can you imagine? Everybody imagine a cone. Everybody got it? A cone? If I chop it straight through, what shape did I make? Circle. If I chop it at an angle, I made an ellipse. All right. Anyway, that's in our future. Okay.
So for E?
This one?
Yeah.
Ah, yeah. What do I wish was in front of the angle?
Yeah.
Well, put it there. So take the tangent of both sides. Do you see what I mean? What do I wish was there? Tangent. All right. Take a tangent of both sides. All right. What's tangent theta? In terms of y and x. What's tangent theta? In terms of y and x. And what's tangent of pi over 6? Oh, we just talked about it. We just did it. We just did it.
Root 3 over 3.
Yeah, rad 3 over 3. So look what this is. If I multiply the y up, what shape is that? It's a really strange question, but what shape is this? Y equals number x. Y equals mx.
Line.
It's a line.
So why did we use tan instead of
Because if I want to use sine or cosine, it's also missing an r, and if I multiply both sides by r, this side becomes nothing. Becomes nothing good, I should say. The thing that I need to do least to this would be just throwing a tangent on both sides. This one I'd have to take a cosine and then multiply by r, which would really be gross. By the way, what is r in terms of x and y? Not r squared. What's r? R. Yeah, it's the square root of x squared. Now, to be honest, in general, it actually could be plus or minus. Do you guys remember what a negative r means? So like this problem.
Oh, yeah, you're going back.
Face 2 pi over 3 and then walk backwards. Yeah, that's why I ended up here. Okay. All right. So. Oh, okay. Oh, yeah, let's do this. Let's take this. All right. I got a few things I want to do, and then we'll get into some new stuff. This is the new stuff. Here we go. And now we wait. This is the best part of the class. Come on, you can do it. Hey, all right. So, if you hit mode, look here. If you want a calculator, by the way, I got something. If you want to play along, we're not going to do too much with this though. If you go down to polar, now when you hit y equals, so if I put in here like, I don't know, what's the equation we just had? We were just working on it, Jeff. Here it is. Yeah, okay, let's do r equals 5 sine theta. So r equals 5 sine, and now when you hit this button, it's going to be a theta. So this is your all-purpose variable button. Somebody who wants to play along with me? So if you change, I don't know if you saw, if you change your mode to polar, now when you hit y equals, it's actually r equals. Now everybody do this for me. Hit zoom 6, and then you should end up with this. Now that is a circle. Why does it not look like a circle? Does anyone know? Doesn't that look more like an ellipse?
Is it 5?
Looks more like Stewie's head, right? Look at you, fat butt. Say again?
Is it 5?
No. It's because the screen is not square.
Oh,
You see that? It's rectangular, so it kind of smushes it. You with me? Okay. Now, what is that circle centered on? What axis is that circle centered on? It's almost a tongue twister. No, it's not center of the origin. What axis is the center?
Y-axis?
Y-axis. The equation, why do you think that's centered on the y-axis? What is sine like?
Y.
If I make it cosine, what's going to happen?
It's gonna be more on that side.
Holy shit! Now, and also, watch this. If I make it plus 5 sine theta, anybody have any thoughts? What's going to happen? It's going to shift. It's 5 cosine makes it shift on the x, 5 sine makes it shift on the y, so this is going to shift both. And it's bigger too, isn't it? Which makes sense because it's adding 2 things. I don't know if you guys are with me or not. So the cosine part made it move this way, and the sine part made it move that way, so now it's centered there. Okay, maybe? So there's a lot of cool shit that unfortunately we just couldn't get to. It's too bad. Here, while I'm doing this, I'm going to go to something that's much better. Jeff, how much time do you have? Never enough.
Facts.
Yeah, if we had more, you could do it, Jeff. Computer labs, we would definitely be teaching this in computer lab. So if you go to, yeah, look at that.
I think this is in the book.
Huh?
I think this is in the
Yeah, it's in that one section that I made extra credit. Now watch real quick. How many leaves does it have?
4.
4. And what's the number I put in?
2.
What do you think is going to happen when I put 3 in there? No. Ha ha ha. Sorry. So every even number doubles and every odd number doesn't. It's just, real quick, this, when you put something in, that's changing the what of the sign. When I put a number where I did. No. When I put like 3 there, what does that change? No, come on. Sine of theta. What's the
number of loops.
What's the period of sine? 2 pi. What's the period of sine 3 theta? 2 pi over 3. Remember k? So it's going to get through its stuff quicker. In this case, it's actually retracing those. Okay, really. When I put a 2 in there, were there 4? Because it did not retrace. It made 4 distinct leaves. When I put a 3, you would think there should be 6 leaves, correct? But when it went to make another leaf, it actually just overlaid the one that was there already. There are 6 leaves. They just, 3 of them overlap what's there already. So if I put in there 8, how many leaves should there be? 16. But if I put in there 9, now there's 9. I'm sorry, yeah, 9. Okay, maybe. Yeah, I think so. This is too bad, because this is cool. I don't know if you guys ever heard of spirograph?
Yeah.
Okay.
Yeah.
And anyway, so it's this basically, then you can start putting the stuff together and getting really funky shit. Okay, that's a little big. Let's bring this down to 2. There we go. Now we're getting some stuff. You guys with me? Now what if I put 5.3? Sorry. Let's put 1.3. There we go. Now that's cool. Look at that. Isn't that nifty? And you're all like, oh my God, whatever, dude. I'm just going to stand up here the rest of it. No, okay. I can play with that shit all. Okay. So that's that one section we skipped, which is where we would have actually done some of this stuff by hand. Which sounds really exciting, I know. Okay. But, it's not that big of a stretch, and I've got a few of these I'm going to give you guys right now, I guess. It's not that big of a stretch to imagine if I can plot, Jeff, if I can plot points, if I can plot individual points, then I can plot points that come from an equation. I can connect them together. Yes? I can make an r theta table, and I could plot points, yes? Okay. So I'm almost certain some of you guys have not gotten to this polar graphing section yet. So I'm going to give you, I can't remember how many I did. This is front and back. So if you're smart, you should be able to use this to plot several problems. I didn't forget you, John. It's coming. You're good. I got more if anybody wants more, you can come grab it. That should help out with that homework. So the homework you got to do, some of it's going to be plotting polar points. Yeah, it's a lot of weird. There's alliteration. There's all kinds of stuff happening. Plotting polar points. The next section would have been actually graphing equations, because that's exactly what we did when you learned XY. What's the very first thing when you learned XY? Plot -2, 6. Okay, right? And then you did, what if it's y equals 7x? Let's make points and plot, and look, it makes a line. That's exactly what we would do with this. If I get points that come from an equation, they should have some pattern to them. Exactly like the ones we just saw with the leaves, right? But time-wise, you guys didn't get to play with that as much. I'm sorry. Okay. What was the last thing, Jeff? Blah, blah, blah. Oh, that's right. One more thing on this. Gosh, oh my God, how much time am I leaving myself? Oh, okay. It's pretty good for me. Let's see. Last thing I want to show you, and I often forget to do this. I'm not sure what reminded me to do this. Do you remember I showed you a while back you could solve equations in your calculator? If you put one side of the equation on y1 and the other side on y2, you can see where they meet, right? So let's go back to function. So what if I wanted to solve something like we did earlier. Cosine 2x equals 1/2. Right? Okay, so let's see what happens if I try to graph this thing. Do you see why there's an infinite number of answers? First thing. So the blue line, crazily enough, is the cosine. The red line is 0.5, it's 1/2. So the answers to the equation cosine x equals 0.5 is everywhere those two meet. So don't they meet like here, for example? Yes, they do, Jeff. It's crazy. If I add 2 pi to it, doesn't that just become that? So that's exactly what we do, don't we? We find one answer, and here's another answer. Are they equally spaced? No. So I'll write that answer plus or minus 2 pi k, and I'll write that answer plus or minus 2 pi k. Because I can go that way too. And one reason I don't think to do this is because I don't want you to solve it necessarily in here, especially when the answers are something you're supposed to know. I want exact answers, correct? But you could do like the 1/7 problem we did and check your answers, right? You see what I'm saying? Maybe. Okay. Just want to show you that, but it's a really nice visual of why the hell do we do plus or minus 2 pi k? Why are there an infinite number of answers? There. It's going to hit forever, ever, 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 ever. All right. All right. So, bless you. Today, we're going to talk about today. Is something really neat. And just to remind you guys, if you didn't see this, test is now Wednesday. It's going to cover 9.3 up to 10.3. So only that homework is due Wednesday. We are going to talk about parts of 10.6 and 10.7 today because, you know, I'm a jerk. And then, but only 9.3 to 10.3 homework is due Wednesday. After 10.3 homework, whatever we do is due on the day of the final. Okay. So let me ask you this. Okay. You will do what I say. Okay. What was one of the main things about polar coordinates? Remember when I was standing here and I was talking about getting to somebody, right? So if there's a point in space, there should be multiple ways to describe where it is. So if there's a point in this room, if one of you guys are sitting, so I could talk about how deep into one row I've got to go and then how many rows I've got to go over to get to somebody. So to get to you, Imran, I'd have to go in 1, 2, 3, and I have to go over 1, 2, 3. So you're basically the point 3, 3 if I'm the origin. Or, if I want to jump over some chairs, which I'm going to have to do anyway, I could just turn, say what angle do I have to turn to look at you, and then go to you, right? You guys all kind of with me. Beyond that, the next step above that is, how do I capture a series of points? So what we're used to is something like y equals 2x plus 1. Ooh. So that would capture a sequence of points, correct? Okay, I like it. This one, the way this is written, what's dependent on what? Y depends on x. I love it. Now, of course, we could solve it for x, and then x would be dependent on y, but you guys all with me? So, this is kind of cool. Do you guys know what an Etch-a-Sketch is?
Yes.
Does anyone not know? It's okay if you don't, because it's one of those things we had before we had, you know, Xboxes and shit. We had Etch-a-Sketches, and we had, no, I didn't want that one. Damn it.
Yeah, it has the 2 knobs.
Yeah, and then you shake the sand to like make the picture go
Yeah.
away.
Let me find it.
Yeah, I've seen that.
All right, if you don't know, Jeff, what are you doing, dude? There it is.
I was like, wait, okay, I know what you're talking about. I think I just didn't know the name of it. 'Cause I haven't heard it.
All right. If you don't know, I used to have a little one that went on my keychain. It was a little tiny one, and then I lost it, and I never thought to get a new one. But there are some, and of course this morning I was doing so much I forgot to look. So here's what an Etch-a-Sketch looks like, but they actually have online, here we go. They have online Etch-a-Sketch. Let me see if I can find, I found one that was so freaking cool. It might have been this one. No, I don't want to allow you to do anything. Here we go. Oh yeah. So you can actually, let me see. There it is. Can you guys see them? Whee! If I hit both the up and the over arrow at the same time, of course I go diagonally, right? You guys with me? Is there a simple y equals x that would capture what I just did?
Yeah.
Not y equals x, but do you think there's a simple
No.
equation that would capture all the points I just created? No. Isn't there a simple equation though for like capturing just the x points I did? Because it only cares about this direction, right?
Yeah.
And for the y, same way. So if I separated the two, in fact, does y depend on x?
Wait, okay,
No. In fact, okay, guys, I'm sorry. Aren't I the person that's turning the knobs?
Yeah.
So don't both of them depend on me? How quickly and which direction I'm turning the knobs? Yes? You guys follow what I'm saying? So I am like this subversive behind the scenes, right? I'm the puppeteer. No. Right? So I'm the one who's actually making this thing go through points. The x isn't changing and then making the y change. I am changing both of these damn things. So y is a function of me and x is a function of me. Does that make any sense? If I just don't want to turn the x, then it can't do shit, and I can just turn the y and go, hey, all right.
Yeah.
So they're both dependent on some third thing. Does that make any sense? Because x changing does not change y, does it? If I move the x, does the y have to change? No. I can choose whether to change the y and the x. So I'm some third variable. Just my whimsy is the third variable, right? Now, unfortunately, I can't really, I'm glad I found this. I can't, because I always forget what this is. I can't really control it that well, so I can't go at different angles easily. Look, I made stairs. Okay. Here, I'm actually really good at it. Let me make the Mona Lisa real quick. I am so joking. All right. So just in case you've never seen Etch-a-Sketch, I think you probably have, maybe? But again, this is before we had Game Boys and shit. This is what we had. Shake it and make something else. All right, so let's talk about the math behind what the hell I'm talking about. So now, instead of this, I'm going to have something like this. I'm going to have x is a function of t, y is a function of t.
Are we doing it to 10-6?
Yes. That was my promise, was we're going to cover some of 10.6, 10.7 today. Just to remind you guys, real quick, 10.6, 10.7 homework, not due Wednesday. But I want to throw some of these ideas at you. And again, I think this is going to be relatively nice after some of the stuff I put you through. Well, you put yourselves through it because you signed up for it. So let's do a concrete example. Dear God, Jeff. So what if x equals t minus 1 and y equals 2t plus 3? So now when I go to make a table, I'm going to make a t, x, y table. Damn it! But when I go to graph, when I'm messing with the Etch-a-Sketch, do I actually show up on the Etch-a-Sketch? Do I show up? Is Jeff in there somehow? No. You just see the x and y's, don't you? So let's see. And normally a lot of these are going to give us I'm going to give us an interval over which we exist, okay? Just to make this a little easier. So I'm going to go from 0 to 4, sure. So when I plug a 0 in, what do I get for x?
0.
When I plug a 0 in, I get -1, yes? You guys see that? When I plug a 0 in for y, what do I get? 3. So you think of t as time. So at time 0, the pointer was at -1, 3. And then I turned it. So now, at t1, where's x? When I plug it 1 in, I get 0. Does everybody see what's happening? So am I letting x change and then seeing what y does? No. I'm doing something different. Both x and y depend on some third thing. They don't control each other directly, at least not yet. When I make T1, what's Y? That's crazy. 2, I get 1, and I get 7. 3, I get 2, and I get 9. 4, I get 3, and I get stuff. Okay. By the way, this should be easy once you see the slope is 2, so it should go up by 2 every time. Do you guys see that? So how do I graph this? All right, well, first off, I got to make a decent scale. So this looks pretty good. Jeff, let's zoom out. You get way up here, dude. Put a little phone, go over there. You guys all with me? So mathematically, this is exactly what I'm saying. This is me. At time 0, I put it so the pointer was there. Then at time 1, I did it so that now the points are here, and so forth. So we got this behind the scenes dude. When I go to graph it, T is not going to show up. T is behind the scenes. So then what I often do for myself is I do this. Just so my eyeballs look in the right place. Those are my points I'm going to graph. Do you see that? So -1, let's make a scale here. This could be nice, -1. 1, 2, 3, 4. And then this would be, let's say, 2, 4, 6, 8, 10, 12. It's almost a good scale. Okay. So -1, 3, 0, 5, 1, 7, 2, 9, and 3, 3, 11. Now, what do you notice about that? Considering my scale sucks a little bit, aren't these still linear? Okay. Now, this example is very basic and very boring. It's a straight line. Let me see if you guys can handle this part. Is there a way to eliminate the t variable? We've done this kind of thing before. When we have too many letters and we want one of them to go away. We've done it when we had like the Mount Doom problem, or the airplane looking down problem. We had 2 equations. It had h and x in it. How do I kill one of them? Well, I solve for it. So I want to kill t. So let me solve for t. How do I solve this one for t?
Add the 1 over.
Add 1. And now in this one, I know that t is x plus 1. So what do I end up with?
2x plus 2 plus 3.
Yeah, which is this, isn't it? 2x plus 5. There's a 5, y-intercept, up 2, over 1, up 2, over 1. Let me stop for a minute. Yes? Yeah, so I said t would exist from 0 to 4. So most problems are going to give you some interval for t.
But how are you using it to graph it?
Well, here, if t is 0, what's x? If I make t 0, what's 0 minus 1? -1. And if I make t 0, 3, right? So I just let t change and see what x and y do. And then that's why I said you don't care about that one. These are your points that you're going to graph, right? So t creates each point, and then I plot each point. T doesn't show up. Like I did not show up on the Etch-a-Sketch screen, thankfully. That would be weird. Y'all come up here and go, Jeff! Oh, shit. Okay. So how do I make this more interesting? Well, I make the functions that x and y are built on more interesting, right? So what if I had, for example, x equals 1 minus t squared, y equals, you could do it, Jeff, I don't know. Sure, t cubed plus 2. And we'll say t goes from, what sounds good, Jeff? I don't know. Let's do Barf. Let's do negative 2 to 1.
What is the thing next to
Oh, sorry. This little dude,
Yeah.
I'm sorry, is an element of. It's a nice little shortcut for saying is an element of. So what am I allowed to plug in for t? Well, t is an element of these numbers, so I can plug in any of those numbers. You with me? So can t be 0.71893?
Yeah.
Yes.
Oh.
Can t be 1? Well, can t be 0.9? Yes. You see what I'm saying? So this does not mean, but normally we use nice numbers. So here's an example of a time when you might want to use, you could do it, Jeff, more specific things. You maybe don't, so I'm gonna do this. -2, -1, 0, 1. But I'm gonna leave space. Do you see that? I might need more detail, but we can start with these. What time is it? Oh boy. Okay, this will be the last example. I'll give you guys a homework, worksheet. So let's see. When I plug a -2 in, what's up? You all right? So why did I put these numbers down? Because they are the nicest numbers that are in the set of everything t can be. Correct? Why did I leave room? I left room in case I need more resolution. Maybe I've got to put halves in there, because maybe I can't really tell what the shape of this is. Does that make sense? A little bit, okay. So if I make t -2, be careful. It'll be 1 minus 4, -3, yeah. I understand where 5 came from, but no. And if I make t -2 here, what do I get? Kick ass. -1, that would be 0. Is that cool? -1, that would be 1. 0, that's 1. 0, that's 2. 1, that's 0. And 1, that is 3. Double check me. Do you see already? It's a little weird. It repeats. So these could look like anything. This gives you so much more control over the shape you end up creating. They could look like anything, right? So if you have a spaghetti-looking function, you could probably figure out a set of By the way, these are called parametric equations. Do you all agree with me that the only two real variables here are x and y? They're controlled by some third thing, and very often we call this type of thing a parameter. That's why these are called parametric equations. T acts as the parameter. X and y are the variables that depend on what the parameter's value is. So let's see. If we try to start to graph this, let's see if I need any more detail. So let's see. My y's go pretty far, my x's don't. Okay, so that seems right. Well, that's as far out as I can go. Up we go. Okay. So let's see. Okay, -2, -1, 1, 2, and then we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Sure. One, two. Look at my shoe. Okay. Good Lord. And then again, just to make sure it's really, trust me, I know all too well. Your eyeballs forget where to look. You start plotting 1, 0 instead of 0, 3, right? So do this for yourself. Even cover this shit up. So, oh shit, Jeff, -3. There it is. So -3, -6. So I had to add a -3 in there. 0, 1. So look how far apart those are. Do you guys see what I'm saying? I don't know how these connect. So do you agree with me that I need another?
Wait, was that -3 to +6?
Oh shit. Thank you. Got too many things I'm thinking about. So let's actually put that in the right place. -3, -6. These are still pretty far apart, correct? I want information between those two, so that's why I left room. So I'm going to do negative 1.5, and of course now I'm going to get some calculator help. Oh, let's see, Jeff, you could do it. I don't know if I can, dude. 2.25. I think that's negative 1.25. If somebody would help me. Is it? This one might be too much for me.
3.25.
Thank the gods.
Oh
Wait, wait.
No, sorry. That was. I was doing the first one.
Oh, the first one's 3.25? But it should be, again, it's 1.5 squared. It's 1 minus 1.5 squared. The negative cancels. The negative squared is positive. So this minus is still there, right?
Mm-hmm.
So do 1 minus 1.5 squared.
Yeah.
Yay! Sorry. And then help me out. What's negative 1.5 cubed plus 2? Now the negative matters because the cube keeps it negative, correct?
Negative 1.375.
Neato. So now I could plot negative 1.25, negative 1.375. So about right. You could do it, Jeff. Right there. So now I have a little more, so maybe it looks like it kind of curves like that. Do you agree with me that no line should be straight? Do you agree with me the line should not be straight? Because they're squares and cubes, yes? Do you understand? Okay. Now the next point I would have would be 1, 2. And that seems pretty good, yeah? Do you see how there's not much room between those? 1, 2. So it looks like it's going, wee. Jeff, you're looking up there, dude. You shouldn't do that. And then it goes 0. Ooh, now this gets really interesting. It goes from 1, 2 to 0, 3. All right. It does not suddenly go back. Let's see. I need more information in here for sure. So let's put in there 1/2. So this would be 0.75. And this, Jeff, show off, buddy. 2.125, I believe. Again, I'm just plugging in a number between 0 and 1 because let me make sure you guys, I'm not going to expect a ton from you from this, obviously, because it's a little bit quick. But, well, that's right. We got more we could do. From 1, 2 to 0, 3. That is a weird thing. And what this could actually do is it could actually do like a hurricane and come around and go back. And you guys know hurricanes exist now because we sort of got hit by one almost kind of. Okay. So now let's plot this. 0.75, 2.125. 2.125, so right there. So it does look like maybe it goes, basically it just takes a hard turn. That's interesting. So it goes, wee. I think what it probably does is it probably does do a little loop, but we can't capture that with our horrible scale. That's too bad for us. Now watch this. If this is like time progressing, can't I tell you what direction this thing is moving? Couldn't I do this? In fact, let me make it more specific. You have to do this. You have to indicate which direction it's moving. Do you see how this is immediately applicable to things like hurricanes, missiles, somebody shooting at me, and so forth? Right?
Did you plot the point that's after 0?
In between here?
The one that's 0.75.
Yes, I did. It's right there.
Okay.
Roughly, yeah. Yes?
Since -1 to 0 are like clear points, is that the reason why we didn't have to add another point in between?
Yeah, those I felt pretty good about. That's why it's a good idea to leave room between your inputs if you just want to pick the whole numbers, because you might need more resolution. So let's check our work. I have a feeling it's a little more interesting than what it looks like on our paper. But again, when we're doing stuff by hand, I'm not going to want perfect answers anyway.
If it's so like if you were taking a test on 10 point
6, 7, yeah.
if your graph had like a open space, you would start adding more points. Or are you supposed to just go in using decimals?
Oh, I would do it exactly the way I did it. I like to start with the nice whole numbers, but I'll leave room. And if I get to a point where I'm like, okay, that's weird, I'm not sure what's going on there, it's too big of a step, let me throw another number between to get better resolution, right? There's no way you can know ahead of time what's the appropriate step size.
Okay.
Yeah. So let me show you a couple things that will make you instantly more okay with this. So let's try to plug this in. Oh yeah. So right now I'm in rectangular and what the thing calls function. You guys see how I can make it parametric? Bam. So now when I hit y equals, I'm going to get x and y. So what was this? X was 1 minus. And now when I hit this button here, it's a t. It's crazy. 1 minus t squared, that was our x, correct? Y was t cubed plus 2. All right. And if I go to window, I can actually set what t min and t max are. And I said it was from negative, what did I say, 2 to 1? Right? Don't worry about t-step. T-step being kind of small is good. Because that's basically how big of a step size it does to calculate the next point. We did a step size of 1, which is really, really low resolution. It's like playing a really old video game. Mario is not high resolution when he first came out. Okay. So hit graph, let's see. Oh, look at that! Look at that! Sorry, I'm excited. I want to zoom in though. See, our graph is pretty good. If I zoom in right on this little weird spot here, I'm very curious if there's a loop we can't see. I'm going to zoom way the shit in here. Enhance, oh shit, get out of it. I'm going to zoom in right on that sucker. Let's see what it looks like. No, it's an actual hard turn. Okay, cool. So I was wrong. These things happen. But you never know. Maybe it'll loop around and come back. But, I mean, that's pretty cool, right? No? You guys know. Oh, come back to normal. Oh, no. Oh, shit. Because when I do that, I change the t's. There we go. If I change the step size, by the way, if I make the step size 1, it just reduces the... Oh, shit. What did I do?
It's negative 2 to 1.
Negative 2 to 1. Thank you. If I make the step size 1, it just makes it lower resolution. So I think the step size starts off as like 0.13. So if we make it better, 0.05, makes it supposedly better. Okay. So again, you could play, not surprisingly, kind of the next level of this would be to use sine and cosine, right? Let's see what I get. What will I create? Nita. Look at that. If I let it go out to, wait a minute. I didn't even mean to do this. There, I did some graffiti. That's a W for me. Right? That's pretty freaky looking. If we go negative 5 to 5. There we go. Look at that. Look at that little dude. Sorry. I'm just playing around. By the way, real quick. Sine and cosine. I'm going to say something. Sine and cosine are bounded. They are contained. What do I mean that? What's the biggest sine could be output-wise? 1. What's the biggest cosine could be? Biggest cosine could be? 1, right? From negative 1 to 1, correct? Do you see if I create a parametric system of equations using sine and cosine, they will be contained. Because, so the x direction is controlled by sine. So it can go between negative 1 and 1. The y, now be careful. In the y direction, how far can it go? What's the amplitude on the y? 2, and it's been shifted by 1, right? So it's going to go from like negative 3 up to 1. And let's see if that's what it does. Yes, negative 3 up to 1. Do you guys see that? Okay. Now, here's what's really interesting about what we just did. We just did section 10.6 and 10.7. And of course, I do have a handout. The waning moments of our class here.
So when you give us t element of something, it means the numbers you choose for the table has to be within that.
if they give you an interval for the t, then yes, you can only use those values that t live within. If that's your question. Sure.
So on this page is TZ.
TZ? Oh wait, sorry. This side, please don't even worry. Make sure you don't lose this though. You bring it back. This is chapter 11. I just didn't want to waste paper. So we're going to come back to this. Here is the parametric stuff.
Okay.
Sorry? Oh crap. What did I do? Okay. Oh no, dude. Come back. Okay. So this is, do you see how I have a sign in there? Blah, 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 blah. Yakety so what we'll probably do, considering it's already that time, is, let me give you guys the answer key for the practice test. Tomorrow's going to be a review for the test. Test is Wednesday. Thursday we'll come back to this. We'll do this and then we'll keep going. Because we're crazy people and it's already almost December. So I know it's a little weird. I'm going to give you one more day for the test. I had to do some new stuff today to keep us on a little bit on pace. But you actually don't have to worry about everything we talked about today until later. By the way, I didn't do number 8 on here. We'll do number 8 together tomorrow. And I didn't do the polar clock stuff. We'll do that tomorrow. Oh boy. Man, I'm gonna crash hard tonight, coming back from Thanksgiving.